Hi everyone, today we'll explore the differentiation of stationary points. Think of it as pinpointing, where a function pauses in its journey. These moments reveal significant insights into the function's behavior. Let's uncover how calculus unveils these critical points. So let me introduce my group members. Myself, Parisha Anna Perempuan Sundaraju. My matrix number is F1135. And the second member is Vikneswaran Anna Lalaki Ravichandran F1153. And the third member, Tivian Anna Lalaki Robert, matrix number is F1156. And finally, Aida Akila binti Muhammad Faizul Azmi F1052. Stationary points, also known as critical points, are points on a curve with zero gradient or slope. Differentiation is used to locate these points by calculating the derivative of the function and setting it to zero. Stationary point can be characterized as maximum points, minimum points, or points of inflection based on how the function behaves around them.
Alright, so the next one will be types of stationary points. We got three types of stationary points. The first one will be maximum points. It is positive just before the maximum point, 0 at the maximum point, then negative just after the maximum point. The value of dy dx is decreasing, so the rate change of dy dx with respect to x is negative, which is d to y and dx2 will be 0, negative. And the second one will be two minimum points. Just before a minimum point, the gradient is negative. At the minimum, the gradient is 0, and just after the minimum point, it is positive. The value of dy dx is increasing, so the rate change of dy dx with respect to x is positive. d2y dx square is 0, positive, as you can see in the pictures down there. Maximum point and minimum point. At some point, dy dx is equals to 0 and d2y and dx2 is equals to 0 too. Two such points are shown in the sketches. They are called points of inflection. Note that d2y dx2 is also 0 at some maximum and minimum points. To find the types of stationary point, consider the gradient at each side of it. As you can see, point of inflection picture is below.
Steps to sketch graph. 1. Find the stationary points. 2. Find dy over ds and put it equal to 0. 3. Solve the resulting equation to find the x coordinates of the stationary points. 4. Find d square y over ds square and substitute each value of s to find the type of stationary point. 5. Use the curve equation to find the y coordinates of the stationary points. 6. Find the points where the curve meets the x-axis and the y-axis. 7. Sketch this curve. Example 1. Question 1. The radius r centimeter of a circle is increasing at the constant rate of 3 centimeters per second. Find the rate at which the area of the circle is increasing when its radius is 13.5 centimeter. The solution is, they were given the r over the test 3 centimeter, dA over dr equal to 2 pi r. So, dA over dt equal to dA over dr times by dr over dt. dA over dt equal to 2 pi r times by 3. dA over dt equal to 6 pi r. So, dA over dt r equal to 13.5 equals to 6 times by pi times by 13.5 equal to 81 pi. Example 2. Find the coordinates of TH or minimum point of the graph. So, y equals to 2x power of 3 minus 6x power of 2 plus 6 dy differentiate it and it will become dy over dx equal to 6 power of 2 minus 12s. So x1 equals to 2, x2 equals to 0, x2 equals to 2, replace it to s. So y equals to 2 times by 2, s equal to 2, replace the s. So y equals to 2 bracket 2 the power of 3 minus 6 bracket 2 bracket power of 2 plus c equals to negative 2. So the coordinates will be 2 and minus 2. So s equal to 0, replace them. So y equals to 2 bracket 0 bracket power of 3 minus 6 bracket 0 bracket power of 2 plus 6. So the answer will be 6. So the s will be 0 and y will be 6. So as you can see, the final answer on the left side for equation y equal to 2x power of 3 minus 6x power of 2 plus 6.
Differentiation of stationary points is a fundamental concept in calculus used to analyze the behavior of functions. When finding stationary points, which are points where the derivative of a function is 0, one can classify them using the second derivative test or the first derivative test. The second derivative test involves examining the concavity of the function to determine whether the stationary point is a maximum, minimum, or inflection point. The first derivative test involves analyzing the sign changes of the derivative around the stationary point to make similar determinations. These tests provide valuable information about the behavior of functions at critical points, aiding in optimization, curve sketching, and understanding the overall characteristics of functions.